It's kind of wild to imagine a time, not that long ago, when we thought science had it all figured out. Seriously, the great building of physics seemed totally complete, just a few little odds and ends to tidy up. But as it turns out, those tiny little details, they were about to bring the whole house down. So let's dig into how a few small cracks shattered everything we thought we knew. Right around the turn of the 20th century, the scientific community was feeling pretty good about itself. The laws laid down by giants like Newton and Maxwell, they seem to explain pretty much everything, from planets zipping around the sun to how a light bulb works. It was like they'd found the instruction manual for a perfect clockwork universe. And all that confidence really rested on a few core ideas. First, determinism. This basically means if you know everything about right now, you can predict the future with perfect accuracy. Next, energy was thought to be smooth, continuous, like a ramp, not a staircase. And space and time, well, they were absolute, unchanging. The same for me, for you, for everyone, everywhere. And light? Oh, light was just a wave. Simple. And these ideas were great for building steam engines, but they were about to fail and fail spectacularly. So what happens when you start looking closer? At things that are really, really small or moving incredibly fast. Well, that's exactly where the cracks in this seemingly perfect foundation start to appear. This brings us to the first part of our story, a world that physicists thought they had completely mapped out. But then came a series of really nagging, unexplainable results from experiments that started to challenge, well, everything. Our first mystery has a fantastic name, and trust me, it was dramatic. It's called the ultraviolet catastrophe. The problem was pretty straightforward. When you heat something up, it glows, right? Classical physics had a theory for the light it should give off. The only problem was that theory wasn't just a little wrong, it was catastrophically, infinitely wrong. And the scale of this failure, which you can see right here, it was just staggering. The classical predictions said that a hot object should be blasting out an infinite amount of energy, in ultraviolet light. That's just absurd. But in reality, the energy output actually dropped off a cliff. Theory and reality were not even in the same ballpark. Okay, next up, mystery number 2, the photoelectric effect. This one sounds simple. You shine a light on a piece of metal and electrons pop off. Easy, right? Well, not so fast. Once again, the classical theory about light being a wave made predictions that just did not match what was actually happening. So classical theories said a brighter light, a more intense wave, should knock out electrons with more energy. Makes sense. But experiments show that just wasn't true at all. The energy of the electrons depended only on the light's color, its frequency. And even weirder, the electrons were shot out instantly. There was no time delay for them to kind of soak up the wave's energy. It made absolutely no sense. But the biggest mystery of all, the most fundamental one, was the simple fact that you and I and this whole world even exist. Because according to the laws of classical physics, the very atoms that make us up, they shouldn't be stable. Okay, so here's the deal. Classical physics predicted that an electron orbiting a nucleus should be giving off energy constantly, kind of like a tiny radio antenna. And losing all that energy would make it lose speed and spiral into the center in like a fraction of a second. All matter should just collapse. But obviously it doesn't. Our world is stable. This wasn't just a rounding error. It was a total catastrophic failure of the theory. So these massive failures created these deep, deep cracks in the foundation of physics. The old rules were officially broken. And out of that chaos, a revolution was about to begin, the quantum revolution. The first real crack of light came in 1900 from a physicist named Max Planck. To solve that whole ultraviolet catastrophe thing, he came up with a really radical, almost desperate idea. He said, what if energy isn't a smooth, continuous flow? What if it comes in tiny individual packets? He called these packets quanta. It was a bizarre idea that went against all intuition, and it worked. It worked perfectly. The quantum age had just been born. Then, a young patent clerk named Albert Einstein took Planck's idea and just ran with it. He suggested that light itself is made of these little energy packets, which we now call photons. And this particle-like view of light, it explained the photoelectric effect flawlessly. And in the process, it gave us this bizarre but true idea that light is somehow both a wave and a particle.
So, what about that collapsing atom? Well, a physicist named Niels Bohr took this new quantum thinking and applied it to the problem. He suggested that electrons couldn't just orbit anywhere they wanted. No, they were stuck on specific energy levels, like stairs on a staircase. They could jump between the steps, but they could never exist in between. And just like that, the atom was stable.
So the quantum revolution was busy solving all these mysteries of the very, very small. But at the exact same time, another huge pillar of classical physics was about to crumble: the idea of absolute space and time.
For a long, long time, scientists just assumed that light was a wave. And waves need something to travel through, right? Like sound through air or ripples in water. So they figured space was filled with this invisible stuff called the luminiferous ether. And the famous Michelson-Morley experiment was designed to finally prove it existed by detecting the Earth's motion through it.
And the result? A stunning, total failure. They found nothing. Zilch. No matter which way they pointed their machine, the speed of light was always the same. The conclusion was unavoidable. There was no ether. This massive failure created a huge crisis, and it swung the door wide open for Einstein's theory of relativity. I mean, just stop and think about the sheer pace of this revolution. We're talking 15 years. In just 15 years, Planck introduces the quantum, Einstein rewrites space, time, and light, Bohr saves the atom, and Einstein's general relativity even solves this nagging little mystery about Mercury's orbit. The entire foundation of physics was rebuilt from the ground up in the blink of an eye. So, out of all this creative destruction, the old, cracked foundation was replaced by two brand new pillars. These are the pillars that hold up all of modern physics. On one side, you've got quantum mechanics, the beautifully weird and powerful science of the super small. And on the other, you have relativity, the mind-bending science of the super fast and the supermassive. And together, they are the bedrock of how we understand the universe today. Now, I know this all might sound like some abstract history lesson, but this is the part where it all connects directly to you right now. From these wild theories to the actual technology you're holding in your hand. Think about it. Without understanding quantum mechanics, we wouldn't have semiconductors. That means no transistors, which means no computers and no smartphones. And that GPS in your phone, it literally wouldn't work without Einstein's theories of relativity, because it has to account for time actually flowing at a different rate on the satellites than it does down here. The technology of our world is built brick by brick on these so-called failures. And that right there is the real takeaway. These moments where the old physics failed weren't an ending. They were a beginning. In science, a failed experiment, a result that makes absolutely no sense, is often the most exciting thing that can possibly happen. It's a giant flashing arrow pointing the way to a much deeper, much richer truth. Which really just leaves us with a fascinating thought, doesn't it? What are the ultraviolet catastrophes of our time? What are the weird experimental results happening in labs right now that just don't fit our current theories? What scientific failures are happening as we speak that are secretly paving the way for the world of tomorrow?